Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about development of lateral surfaces of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. So here we have been provided with a hexagonal prism of base edge 25 mm and axis height 70 mm. So this hexagonal prism happens to be resting on its base onto the horizontal plane with two of its rectangular faces parallel to the vertical plane. So if we locate the hexagonal prism onto the horizontal plane into this orientation, now none of the edges of the base, they will be parallel to the vertical plane. So this orientation of the hexagonal prism is incorrect. So while we are going to locate the orientation of the hexagonal prism onto the horizontal plane in this way, so then we observe that two of the rectangular faces of the hexagonal prism, they will be parallel to the vertical plane. So this is the correct orientation of the hexagonal prism with respect to the two reference planes over here. Now we have been provided with the information that a circular hole of diameter 30 mm, it is drilled completely through the prism such that the axis of the hole, it is perpendicular to the vertical plane, and the axis of this hole, it is going to bisect the axis of the prism over here. So once we locate the axis of the prism over here, then we'll observe that a circular hole whose axis is going to pass through the midpoint of the axis of the hexagonal prism is going to intersect with the hexagonal prism over here. So this way, a circular hole onto the front face and a circular hole onto the rear face of the solid will be obtained over here. Now we are required to obtain the development of the lateral surface of this truncated prism over here. Now let us proceed to evaluate top view and the front view projections corresponding to this hexagonal prism. So as the observer is going to look at this hexagonal prism from the top, both the top face as well as the base of this hexagonal prism, they are going to coincide with each other into the top view projections, and we will be obtaining hexagonal projection of this prism onto the horizontal plane over here into the top view projection. Now we obtain that the vertical edges of this hexagonal prism happen to be 1A, 2B, 3C, 4D, 5E and 6F, where A, B, C, D, E, F points, they happen to lie onto the base of the hexagonal prism, while points 1, 2, 3, 4, 5, 6. So these 6 points, they represent the top face of this hexagonal prism over here. Now we need to locate the axis of this hexagonal prism. So in order to obtain the axis of the hexagonal prism, we need to join the diagonals AD, BE and CF over here. Wherever these three diagonals, they are going to intersect with each other, we are going to obtain the axis points O and O1 corresponding to this hexagonal prism. Here point O represents the axis point corresponding to the top face of the hexagonal prism, while point O1 happens to be the axis point corresponding to the base of the hexagonal prism. Now having obtained the top view projections of this hexagonal prism, let us proceed to evaluate the front view projections of this hexagonal prism. So here from the axis points O and O1, we have drawn the projections of the axis into the elevation projection view. Now we know that the height of the axis of this hexagonal prism happens to be 70 mm. So now once we mark axis height, it is equal to 70 mm into the elevation projection view. Now once we draw the projectors from 6 points of the base and 6 points corresponding to the top face of this hexagonal prism into the elevation projection view. So now we will be able to obtain the elevation projections corresponding to the top face of the hexagonal prism. We will also be able to obtain the elevation projections corresponding to the base points of this hexagonal prism over here. Here we have been able to obtain the location of the axis point O dash corresponding to the top face of this hexagonal prism. Similarly, the axis point O1 dash corresponding to the base of this hexagonal prism has also been obtained over here. Now another thing we can check it out over here, that the vertical edge 6F, it lies on the rear side of the solid over here, and this will not be visible to the observer as the observer is going to look at this vertical edge 6F. So the front view projections corresponding to the vertical edge 6 dash F dash should have been drawn as dotted projection line in the elevation projection view. But we observe that this vertical edge 6F has been overlapped by the vertical edge 2B into the front view projections over here. So this vertical edge 6F has been overlapped by this vertical edge, which happens to be 2B, into the front view projections over here. So in the front view projections, the object line projections corresponding to the vertical edge 2B, that is 2 dash B dash, they are going to overlap with, or they are going to supersede the dotted line projections corresponding to the vertical edge 6 dash F dash over here. Similarly, vertical edge 5E, it lies on the rear side of the solid and it will not be visible to the observer. So we should have obtained dotted line projections corresponding to the vertical edge 5 dash E dash into the elevation projection view. But again, this vertical edge 5E has been superseded by or overlapped by the vertical edge 3C, which is available with us on the front side of the observer over here. So this vertical edge 3C, it is going to overshadow or overlap the vertical edge 5E into the front view projections over here. So that is why the object line projections corresponding to the vertical edge 3 dash C dash, they have superseded or coincided with dotted line projections corresponding to the vertical edge 5 dash E dash over here into the elevation projection view. So that is why we are not able to see any dotted line projections corresponding to the vertical edges 6 dash F dash or the vertical edge 5 dash E dash into the elevation projection view. So now, having obtained the orthographic front view projections and the orthographic top view projections corresponding to this hexagonal prism, let us evaluate the development of the lateral surface of the uncut prism using the parallel line development method. So now we have drawn one horizontal projector line emerging from the top face of this hexagonal prism. Similarly, another horizontal projector line from the base of this hexagonal prism has been evaluated over here. Now the distance between these two projector lines, it is going to define the true length of the length of the or the height of the vertical edges of this particular hexagonal prism over here. Now we are going to start development from the vertical edge 1A over here. So once we locate edge 1A over here, now we know that the edge length for this hexagonal prism happens to be 25 millimeter. So now we will find that the distance between the successive vertical edges will be equal to 25 millimeter. So starting from 1A, the vertical edges we have obtained as 2B, 3C, 4D, 5E, 6F and 1A over here. Now this is the development of the lateral surface of the untruncated hexagonal prism over here. Now we have been provided with the information that a circular hole of diameter 32 millimeter has been drilled completely through the prism in such a way that the axis of the hole, it happens to be perpendicular to the vertical plane, and the axis of the circular hole, it is going to bisect the axis of the prism. So here we have got 70 millimeter as the axis of this prism, as O dash, O1 dash. So once we bisect this axis, so we obtain that at a distance of 35 millimeter from the base, we have been able to locate a point over here onto the axis of this hexagonal prism, and this point will serve as the center for this particular hole having diameter equal to 32 millimeter. Now once we obtain this hole into the elevation projection view, let us evaluate 4 points corresponding to the two mutually perpendicular diameters of this particular circular hole. The first diameter happens to be A dash C dash, and the second diameter happens to be B dash D dash over here. So the 4 points of intersection we have been able to obtain corresponding to the circular hole which is going to intersect with this hexagonal prism over here. Corresponding to these 2 points, A dash and C dash, again we can check that these 2 points, A dash and C dash, they do not have any corresponding existing vertical edge passing through these 2 points over here. So we have to obtain the location of these 2 points A and C into the top view projections, and let us evaluate corresponding to the front face and corresponding to the rear face of the solid. Where do we find the location of the vertical edges which are going to define the location of the point A into the front face projection of the circular hole and into the rear face projection of the circular hole over here? So from the point A dash, if we draw a vertical projector into the top view projections, now we can check this black color projector which we have drawn from the point A dash, it has intersected with this base edge AB which is lying onto the front face of the solid at a point which we have named as point A1 over here. Similarly, this projector line from A dash, it has intersected with the base edge AF which is going to lie on the back side of this particular solid. So this is the rear face of the solid, that is starting from DE, EF and FA. This is the front face of the solid. So onto front face and onto rear face. So 2 circular projections we have to obtain over here. So onto the front face we have observed projection from point A will be located at the point A1. Similarly, onto the rear face, projection from the point A dash, it will be located at the point A2. Now we have evaluated the distance of point A1 from point A, as we are going to proceed from the point A to point B alongside the edge AB over here into the front face of this particular solid. So as we move from point A to point B onto the front side of the solid, so once we have measured this distance A to A1, so we'll mark this distance over here. So corresponding to point A1, a vertical black color generator we have added over here, so that onto this vertical generator emerging through the point A1, point A will be located onto the front face of this hexagonal prism corresponding to the circular hole that we are going to obtain in the front face of the solid. Similarly, onto the rear side we can check as we move along the rear side. So from the point F, as we move towards the point A alongside the edge FA over here, so at a shorter distance from point F or at a longer distance from the point A, either one of these 2 distances we can measure, point A2 will be located between the edge points F and A over here. So between the edge points F and A, at a shorter distance from point F, which is equal to this distance, it is equal to this distance, or at a larger distance from end A, that is distance from A to A2. So this way point A2 can be located either way around. And once we locate this point A2, again a black color vertical generator we have drawn over here. So this is again an artificial vertical edge length which we have obtained, onto which point A will be located onto the rear face of the solid over here. So two additional generators we have added over here corresponding to point A dash. Similarly, corresponding to point C dash, now two generator locations we need to evaluate alongside base edges CD on the front face and DE onto the rear face. So 2 points of intersection we have obtained by virtue of intersection of the vertical projector line emerging from C dash with the base edges CD and DE over here. So the intersection point obtained on CD is C1. The intersection point obtained on DE happens to be C2. So now we can check as we move along edge CD at this distance between C and C1 alongside the edge CD. So we'll be able to obtain point C1 over here. So we can check alongside the edge CD at a shorter distance from the point C, which is equal to this distance. We are able to locate point C1. So once we draw another black color artificial vertical generator through this point C1, so onto this vertical generator, we are going to obtain location of the point C corresponding to the front face circular hole over here. Similarly, when we locate point C2 onto the rear side between the edge points D and E over here, so at a larger distance from point D or a shorter distance from point E over here, so we can check at a larger distance from point D or at a shorter distance from point E, point C2 will be located. The moment we are able to mark point C2 corresponding to this distance is D to C2 over here, from D to point C2 over here. So we can draw a vertical generator onto which point C corresponding to the rear circular hole will be located over here. In order to evaluate all points of intersection into the development surface view, now these 5 horizontal projector lines we have drawn from all of these 8 points of intersection of the circular hole with the hexagonal prism over here. We can check in all 8 points of intersection they are available over here. So now let us start to evaluate the location of each one of these 8 points onto the front side and onto the rear side of the surface of the hexagonal prism over here. So once we draw a horizontal projector through point A dash, because A dash happens to be the first point of intersection. So once we evaluate a horizontal projector line emerging from A dash, so we know that point A into the development surface view will be located onto the vertical projectors which are located corresponding to the points A1 and A2. So A1 vertical projector happens to lie between the edge AB, and A2 vertical projector happens to lie between the edge points F and A over here. So between AB we can check this is point A1. So this black projector line emerging from A1, wherever it intersects with horizontal projector line emerging from A dash, we locate the position of the point A onto the front surface of this hexagonal prism over here. Similarly, onto this vertical projector emerging from A2, wherever the horizontal projector line emerging from A dash is going to intersect, so this intersection of these two projector lines will provide us with the location of the point A corresponding to the circular hole onto the rear face of the solid over here. So one point A has been located into the front face and into the rear face projection of this particular solid. The next 2 points which we want to evaluate, they happen to be the points B and D. So we can check B dash and D dash. they are not lying on any given existing vertical edges of this hexagonal prism over here. So an artificial vertical edge, again another additional one we have generated through the points B dash and D dash over here into the top view projection. So one point of intersection of the vertical projector drawn through B dash and D dash with this base edge EF will be obtained over here. Another point of intersection onto the front face will be obtained onto the base edge BC over here. So the 2 points D1, B1 we have marked over here onto the base edge BC. Another point D1, B1 we have marked onto the base edge EF corresponding to the rear surface of the solid. This is front surface of the solid. This is rear surface of the solid. So corresponding to front surface, D1, B1 points, they will be lying at the midpoint of the base edge BC over here. Where is BC? BC lies here. So let us obtain the midpoint. The midpoint means we have drawn a blue color line. An additional vertical generator has been created over here between points B and C at the midpoint. Similarly, on the rear side, between the edge EF at the midpoint. So between the edge EF at the midpoint, again additional blue generator has been created over here. So onto these two blue generators D1, B1, one in the front face, one onto the rear face. So we are going to obtain the location of the points B and D into the development surface projection view over here. So now from the points B dash and D dash, so if we draw two horizontal projector lines over here, one is this one, another one is this one. So wherever these two projector lines emerging from B dash and D dash, they will be intersecting with these two blue vertical projector lines emerging from D1 and B1. So we will be obtaining the points B and D into the front face projections. We will be obtaining the points B and D corresponding to the rear face projections over here. So rear face means between EF, front face means between B and C. So the 6 points we have been able to locate over here. Now next point of intersection happens to be C dash. So we know that corresponding to C dash, we have already obtained two vertical projector lines corresponding to C1 and C2 over here. So point C1 has been located here, point C2 has been located here. So onto these two vertical black projector lines, wherever the horizontal projector line emerging from the point C dash is going to intersect. So these 2 points, one in the front face and one in the rear face. So they will be located to represent the location of the point C corresponding to the circular hole over here. Now we are left with location of the 4 points P1 dash, P2 dash, P3 dash and P4 dash into the development surface view over here. So we know that points P1 dash and P2 dash, they are located onto the existing vertical generators. Which are these two existing vertical generators? 2 dash B dash, 6 dash F dash over here. So if we draw horizontal projector lines through P1 dash and P2 dash, so wherever these two horizontal projector lines, they are going to intersect with vertical generators 2 dash B dash and 6 dash F dash over here. So we can check, this is 2B, this is 6F over here. So onto this 2B generator and this vertical generator 6B, wherever these two horizontal projector lines emerging from P1 dash and P2 dash, they are going to intersect. So 2 points of intersection P1 and P2 onto the front face over here and 2 points of intersection P1 and P2 onto the rear face we have been able to obtain over here. Now next 2 points of intersection, they happen to be P3 dash and P4 dash. Now again we can evaluate over here that these 2 points P3 dash and P4 dash, they happen to lie onto the existing vertical projectors 3-C- and 5-E- over here. So wherever the two horizontal projector lines emerging from the points P3- and P4- of the elevation projection view, they are going to intersect with the existing vertical projectors 3C and 5E over here. So we are going to obtain 2 points of intersection P3 and P4 into the front face projections. Similarly, P3 and P4 into the rear face projections over here. So this way we have been able to obtain all the 8 points of intersection corresponding to the circular hole onto the front face projections over here. Similarly, the true shape corresponding to these 8 points we have been able to obtain into the rear face projections of this particular hexagonal prism over here. Now let us join all these 8 points of intersection using these circular arcs over here. Why? Because this circular projection corresponding to the circular cutting plane, so they will be obtained as circular arcs over here. So we can check onto the front face, the true shape of the cut section will be appearing like this, and onto the rear face also a symmetrically mirror image will be generated onto the rear face because of the symmetry of this particular surface of hexagonal prism over here. So now the true shape of the hole has been obtained onto the front side and the rear side. Now let us complete the boundary of this particular development, and now we can observe that the vertical edges 1-A- and 4-D- they have not been cut by this cutting plane, that is circular cutting plane. So the vertical edges 1A and 4D, they have been left unintersected over here, and whatever the remaining portion of the existing edges were there, so the 4 vertical edges 2-B-, 6-F-, 3-C- and 5-E-, they have been intersected over here. So now we can see 2B, 3C, 5E and 6F. So these vertical edges, they have been intersected by the circular hole. So the remaining portion of the vertical edges we have also joined using the object lines, and in the elevation projection view now we can join the remaining portion of the solid which has been left uncut over here. So this portion of the vertical edge, this one and this one, it has been intersected and removed by the cutting plane. So this is the remaining portion of the solid which will be visible to the observer while the observer is going to look at this hexagonal prism from the front side. So through this discussion, now I hope that you would have understood about the procedure. How do we proceed to obtain the sectional front view projections, the top view projections, and the development of the lateral surface of this hexagonal prism which has been intersected by a circular cutting plane having diameter 32 mm in such a way that the axis of this circular hole will be perpendicular to the vertical plane, and the axis of the circular hole coincides with midpoint of the axis of this hexagonal prism over here. So this is all for today. So we will be continuing with further discussion regarding few more illustrative cases of development of lateral surfaces of the solids in the coming lectures. So thank you very much. Thanks a lot.